First, I will try to finish the rest of the slides that we left for the lecture last time. And last time we introduced several corrections for the horizontal distance measurement, including the corrections for the temperature, tension, and also the sag, which is from the gravity. And we also show the relationship about the sag and the tension. With that, we will also there will be another thing which we will find out the try to find out the trade-off between the impact of the tension and the gravity. So if we can recall the corrections for the tension, by increasing the tension, you will actually stretch the tape, and your actual reading will be smaller than the true distance. And you need to well, for the correction, you need to add an additional amount to make sure that your measurement is correct. And for the sag, that the effect is opposite. With the gravity, you will have it will actually make the catenary shape of the tape, and this one will actually make your reading from the tape larger than the true distance. So in order to correct the sag, you need to remove the correction that you calculated. So for the tension, you have the positive correction. For the sag, you will have the negative correction. And if you go to see the actual measurement, the impact of the tension and the impact of the gravity will happen at the same time. So if in that sense, it's possible that if we increase the tension, and there's no way for you to remove the errors from the tension and the sag at the same time. And we define the tension which can eliminate the sag error as the normal tension. So as normal tension, and that's the definition of the normal tension. So if we go to check the definitions of the normal tension and the normal tension, the definitions of the corrections for the sag and the correction of the tension, you can find out that all the functions of the tension applied, and in this case the tension applied is Pn, so we apply the Pn to the tape. So applied tension, and this tension will make sure that will help you to find that the value for the sag correction will be the same to the tension correction. And if you try to solve this equation, you will find out the expression of the normal tension, which is the Pn. At the normal tension, you will find out the same value for the sag correction and the tension correction. So basically, if we draw the relationship, between the correction and the tension, for the tension, you will actually find that if we have the correction for tension, if we have a larger tension, you will have a larger correction. But for the sag, what you will observe is like if we have the larger tension, the value of the sag correction will be smaller, and at this interaction, the crossing point, you have Cp equal to Cs, and that value is where you can get the normal tension. So that's the definition of the normal tension. And in the if we are given the normal tension of one tape, then you can try to eliminate, or you don't need to calculate the sag correction or the tension correction. Usually for the very heavy tape, for example, for those tape with a very long distance, around 100 feet, then the normal tension is about 51.5 8 pounds. And if the tension, if the length of the tape is 30 meters, which is quite similar to 100 feet, then the normal tension is about 26.5 kilogram. And for the medium weight tape, the normal tension is around 28 pounds for 100 feet and 12.8 kilogram for 30 meters. And this actually applies for the tape with the cross-section area of 0.005 square inch, and the common modulus of the elasticity as 3 times 10 to the power 7 pounds per square inch. So that's the normal tension, the typical normal tension applied for different type of the tapes. Of course, in reality, if we are given the features of the tape, and then you can actually calculate the normal tension by yourself. And then by knowing all the different type of the errors, we can then see how we can correct those errors from the tension, temperature, the sag, to find out the true distance that we measured from the tape. We will go through two examples. The first one is simpler. Assuming that we have a tape which is about 100 feet long, and the standard length is 100 feet, and it's actually the tape is calibrated at a temperature of 68 degree and with a 20-pound tension, and the observed distance between 2 points of, assuming that we are conducting one measurement from point A to point B, and we have the tape supported at 0 and 100 feet points, and with the applied tension of 30 pounds. And then distance measured is 100.452 feet. And the tape, the weight of the tape is 3 pounds and has a cross-sectional area as 0.01 square inch. And the problem wants us to find out the true distance between the 2 points. Also, we assume that the elasticity modulus as 3 times 10 to the power 7. So with these assumptions, we will then need to think about the corrections for the temperature, for the tension, and for the sag. And then we will use this correction to calculate the true distance that is measured by the tape. So first of all, let's try to find out all the assumptions they provide to us. At the very beginning, we have the standard length of the tape is 100 feet, and then we know the standard temperature is 68 degree, and the normal tension, the standard tension is 20 pounds. And for the measurement, for the actual measurement, so this is the tape property. And for the actual measurement, which is the measurement 1 that we observed from point A to point B, the applied tension, based on the assumption we have P equal to 30 pounds. And we also know that distance we measured is L equal to 100.452 feet. And we know the weight of the whole tape as 3 pounds. And also we have the cross-sectional area as 0.01 square inch. The elasticity modulus is 3 times 10 to the power 7 pounds per square inch. And we want to find out the the true distance. The true distance we want to we measured. So to do that, here you will see that we need to in the solution. In the solution, we have to find out the correction for the sag, the correction for the tension, and the correction for the temperature. In this case, the problem did not specify what kind of temperature is actually applied, so we just assume that is using the standard temperature. So we say that the applied temperature is 68 degree, and if T equal to T0, so T equal to T0, then obviously we can get the correction for the temperature is 0. This is just one information missing in the problem, and we make this assumption. And now we the most important part we need to think about is the values of the sag correction and the tension correction. So let's see how we can solve each one of them. So first of all, for sag. For sag, we have to use the formula W squared times L divided by 24 times P squared. And we actually know the weight of the tape, which is 3 pounds, 3 squared times the mile distance 100 times 452 divided by 24 times 30 square. So that will give you the correction for the sag as 0.042 feet. And the second one we need to calibrate is the tension correction. So we have to recall the expression, the formula for the calculation of the tension correction, which is P minus P0 times L divided by A times E. So we know that the applied tension is 30 pounds and the standard tension is 20 pounds times the length, which is 100 times 452, 0.452, and A is 0.01, E is 3 times 10 to the power of 7. So with that, we get the correction for the tension as 0.003 feet. And now we can calculate the true distance. The true distance of the of this measurement. So the true distance will be the observed distance. And then there's one question for you. How we gonna deal with the sag and the tension corrections? Do we need to add the sag correction or do we need to subtract the sag correction? Any ideas about it?
You add the tension and subtract the sag?
Yes, that's right. So as we described previously, if we have the sag, then it will actually make your reading larger. So you need to remove the correction from the sag. So it's a minus CS. And for the tension, if we have the larger tension applied to the tape, it will make the reading smaller. So you need to add the additional correction. So the CP, what we get is 100.452 minus 0.042 plus 0.003, and that will give you the final solution as 100.413 feet. And if you find any minor errors in the calculation, you can double check. You can just let me know. I may get some errors to find out the exact value. So that's the one simple example for you to calculate the corrections for the sag and the tension, and then you apply them to do the correction. It's a simple one. You just calculate the corrections based on the formulas from the lecture. The next question is a little bit complicated, and this one it will be related to how you do the tape measurement in the field. In this example, we assume that there's a 30-meter tape with a weight of 0.55 kilogram, and it has a cross-sectional area of 0.02 square centimeters, and the standard we found that the tape is not accurate. For the 30 meters distance measured, it's actually 30.005 meters. So this is not quite accurate. And this is actually measured at a 20 degree, and with the 5 kilogram tension. And so if you apply the temperature of 20 degree and the tension of 5 kilogram, then what you will measure is if even you read it as 30 meters, it's actually measured as 30.005 meters. And the tape was used to measure the distance about 89 meters over the terrain of the uniform 5% slope. So this is actually a sloping method for you to measure the distance. And the temperature was 30 degree, and the tension, the tape was always supported with the tension of 5 kilogram, and the observed distance was 30 meters, and 29.5 meters. And then we want to use this information to calculate the horizontal distance between the 2 points. So to do that, first let's just draw a graph about the area you actually measured. So it's actually in the slope, and the slope is 5%, and this indicates that the vertical distance over the horizontal distance, the vertical distance over the horizontal distance will be 5%. So that's the definition about the percentage for the slope. And in this problem, we also assume that the marked distance in the tape is 30 meters, but indeed it measured 30.005 meters. So there's something wrong about the scales in the tape. It's not accurate, and we have to consider this as the error from the instrument. And the temperature we set is the standard temperature we set is 20 degree, and the tension, the standard tension is 5 kilogram, and we also know the weight. The total weight of the tape is 0.55 kilogram, and the cross-sectional area is 0.02 square centimeters. And for the measurement that we are working on, we have the applied temperature as 30 degree, the applied tension as 5 kilogram, and we have three measurements to measure the rough distance about 89 meters. So we have the measurement 1, L1 is 30 meters, L2 is 30 meters, L3 is 29.5 meters. So it means that as the distance is too large, much larger than the maximum distance of the tape, so you need to conduct multiple measurements. So you first measure from, say, from point A to point B. First measure from A to C, and the distance is about 30 meters. And then from C to D, it's another 30 meters. At last, you have the last measurement that is 29.5 meters. So that's the three measurements you conducted to for the slope. And the problem wants us to find out what's the horizontal distance. So as we already know, the slope of the grade of this slope is 5%. So if we can find out the true distance of the slope, then we are able to find out the horizontal distance easily with the grade that we defined. So the problem now becomes how we can find out the true distance of the slope. And we actually applied the tape measurement for the slope, and we conduct three times measurement, and we know the information about each measurement. Of course, the measurement from the tape is not accurate. So what we want to do is that we want to find out some corrections for this tape measurement. So now let's go to see the how we can solve the problem. Still, let's try to just draw the graph. And this is just as one reference so that you can always track what we are doing for now. And for now, let's first go to see how we can do the correction. As what we explained in this lecture, we have the correction for the sag, the correction for the tension, and the correction for the temperature. Well, let's start with the simplest one, the tension. We know the standard tension as 5 kilogram, and the applied tension is also 5 kilogram. So this indicates that if we recall the formula of the tension correction, you can easily find the correction for tension would be 0 because the applied tension is just the same to the standard tension. And then for the second one, which is it's a very tricky component, that will be the correction for sag. Well, remember that at this time you actually do three measurements. So which means that you have to calculate the sag correction for each measurement. So we have three measurements. L1 is about 30 meters. L2 is also 30 meters. L3 is 29.5 meters. So those would be the three measurements that you applied with the same tape. And we define the first two as the full tape, because they apply the all the maximum length that can be measured by the tape at one measurement. And the last one would be defined as the partial tape, because you only use part of the tape to conduct the measurement. And then let's see how we can calculate the sag for each measurement. First for the measurement 1, we define the correction for the sag as CS1. You can actually directly call the formula of the sag correction, which is W squared times L divided by 24 times P squared. And here W, the capital W, would be the weight of the tape. That is 0.55 squared times 30 divided by 24 times the applied tension, that is 5 square. So this is about the first measurement. And then for the second one, because they are exactly the same, so you will obviously will see that it's with this formula, you can almost see that this one is exactly the same to the first one. And for the last one, this is a little bit different. It's just a partial tape in the measurement. So what you need to do is that you have to use the another equation, the little w square times L3 divided by 24 times no, it's sorry, it's w square times L times 24p square. It's still the same formula, but you have to use the weight of the tape that you applied in the third measurement. So that is W3 square times L3 divided by 24p square. The p is also set as 5 kilogram. So W3 is actually the weight of the tape utilized in the partial measurement, so which is the weight of 29.5 meters. So W3 is the weight of L3 length of tape. So in this case, it's a 29.5 meter. So you can find out the weight. W3 will be the total weight of W times L3 divided by the total length. So that is 0.55 times L3 is 29.5 divided by the total length of the tape is 30 meters. So in this case, you will have the result as 0.55 times 29.5 divided by 30 square times the length of the third measurement. So that is 29.5 divided by 24 times the applied force. That is 5 square. So with that, we can find out the total correction for the sac as CS1 plus CS2 plus CS3, and you can apply all the values in these equations to find out the result. So the result is I haven't get the actual result yet. So the result is let me do the quick calculation. It's 0.04499 meters. So that's the correction for the sac. And this is the first step for us to find out the correction of the sac. And we also need to find out the actual correction of the sac. Because for now, the correction of the sac you measured, you calculated is based on the wrong instrument scales. The 30 meters is actually the 30 meters measured is actually the true distance you measured is a 39. It's a 30.005 meters. So your reading is actually smaller, and this kind of difference will transferred proportionally for the sac correction. So what you will find about the true sac correction?
Hi, Professor. There is a question in the chat about what full supported means.
Yes.
Does
Okay.
that imply that there's no sag, or does that imply that the ends are fixed?
Okay. Let me try to finish this simple calculation first, and then go back to check the questions. Okay. So for this one, for the true sag correction, we have the CS, because the distance you measured, you read from the tape about 30 meters is actually 30.005 meters. So you need to increase the value proportionally. So 30.005 divided by 30. So with that, you find out the value of the sag correction as 0.045 meters. Then let me go back to check what's your questions in the meeting chat. So anyone who asked the question, can you can actually raise your hand so that we can know. I can easily find out what question you have. There will be too many. Okay. So Mano, can
Yeah, so there was a question in the chat about what full supported means. So we're just wondering if it means that there's no sag, or does it mean that it's just fixed at the ends?
Okay. The full support means that you actually put in the support at the two ends. So it's say that you have you are not putting the tape. You did not put the tape along the ground. You actually put in the 2 points with certain height, so that you can use you can measure the tension for the tape with the tension with the force that you applied for that measurement. So that's the definition about the full support. And what if we are talking about the full tape? That's a different story. The full tape means that you actually use all the maximum distance measured by the tape. If the maximum distance can measured by the tape is 30 meters, and for this example, you measure the total distance of 89 meters. What you need to do is that you measure for the first one, you apply the full tape, measure the 30 meters. And then for the second measurement, you apply another full tape, that's another 30 meters. And then for the rest, there will be a distance smaller than 30 meters. So you just use a part of the tape to complete the measurement. And that's the partial tape. So there's something difference about the full support and the full tape. I hope that's the confusion part that you asked. Marat, I hope I pronounce your name correctly. What's your question?
Sorry, I was muted. Sorry, why is it more correct for us to apply that 30.005 over 30 factor at the end instead of doing it on the lengths and then calculating the sag?
Yeah, so for now, I just try to make everything clear about the correction of each component from the sag, the tension, and so on. So you know that from the assumption of the problem, the scale of the tape is not right, and it's even though it marked at 30 meters, it's actually measured around 30.005 meters, 5 millimeters longer, shorter. So your reading is actually 5 millimeters shorter. So the correction for the sag is also shorter proportionally, because you are using the scale from the tape to do the correction, and you need to change it back to the true values, and that's the reason we have the calibration process about the tape to make sure that you know what's the instrument errors, and this is just applied for the sag. For the which would be some part I want to introduce later. For the correction of the temperature, we also need to apply the similar process. That would be the part I want to go through right now. Is there any other questions?
Professor.
Yes, yes.
So how do we know that it was like 30.005? Like, what if it was just measured at 30 and then the rest wasn't used? Because I don't think the question like states that it was the full tape was used and then it says 30. It just says 30, 30, and then the like smaller measurement.
Yeah, this is actually explained in the first sentence of the problem. So here you can see that
I see it now.
the calibration process. It's a 30 meters tape found to be 30.005 meters. This is a calibration. We use the true distance to calibrate it. Okay. Any other questions? Okay. If no, I will go to the calculation about the correction for the temperature. So this would be the third one, the temperature correction. We have the applied temperature, 30 degree, the standard temperature, 20 degree, and we have, actually here I did not give you the value of the coefficient. You can make an assumption about the coefficient depending on the, if it's not provided, in this case, if it's not provided, you can use this value. But for most of our homework assignment and the exams, I will give you the values. This problem just did not provide the information. So for the correction of the temperature, we can apply the equation alpha times T minus T0 times L. At this time, you don't need to consider the distance, the correction of tension for each measurement. You can actually put them together because the this kind of if you go to check this equation, it's proportional to the distance you measure. It's linearly proportional to the distance you measured. So you can add them together; they will be the same. If we want to see the accurate the details about it, you can actually calculate the correction for temperature about each measurement, L1, L2, and L3. But if we add them together, it will still be this equation. So as L equal to L1 plus L2 plus L3. So in this case, you have the value of alpha as 0.000116 times the temperature 30 minus 20 times the distance measured 89.5. It gives you the value as 0.0104 meters. And also we need to consider the potential errors of the 30-meter tape measured as 30.005 meters. So we have the actual correction for the temperature as CT times 30.005 divided by 30. That is, if we apply all the values, you can find out that it will be approximately the same. It's still 0.0104 meters. So that's the correction for the temperature. And at last, we also need to think about the potential error from the instrument, and we need to consider the correction for the instrument errors. So this would be the instrument. So we will still need the same figure, 30 meters tape measured 30.005 meters, actual true distance. So the correction for the instrument would be, so you will actually be around 5 millimeters shorter for each 30 meters distance you measured. So you need to find out the ratio for the average error for each meter. So that would be 30.005 minus 30 divided by 30 times the total distance you measured, 89.5 meters. And that gives you the correction for the instrument as 0.0149 meters. And for now, you can actually find out the last step. You can find out the true distance of the slope. So it would be the the distance you measured plus the correction for the tension, the correction for the temperature, minus the correction for the sag, plus the correction for the instrument. We have L is 89.5 and CP is 0, CT as 0.0104. The sag is 0.045 plus the correction for the instrument 0.0149. It gives you the true distance of the slope as 89.480 meters, and then you can actually calculate the distance of the horizontal distance, and the value would be oh, I guess I give you the wrong definition about the percentage of the slope. So the 5%, which will be the 5%, which will be the ratio between the vertical distance and the slope. So this will be something different. Something I've got to I get something wrong in the previous page. So with that we can find out the vertical distance as S times 5%, and that will be the 89.480 times 5%, and you can then find out the horizontal distance. The horizontal distance would be the square root of S square minus the vertical distance, the square of the vertical distance. And with that, you can find out the horizontal distance as 89.368 meters. So that's the way for you to find out the horizontal distance. And this is actually in a very complicated example. We consider the corrections for the temperature, the tension, the sag, and also from the instrument. I will recommend you to go back to do the experiment by yourself again, and try to figure out what kind of equations we need to consider to calculate the correction for each one, and how we can consider the impact of the instrument in the calculation of the correction. So that's the third example. Do you have any questions?
Quick question. What was wrong with the way we related the 5% before? Because I thought it was like 5% slope, right? So rise over run.
Oh yeah, it's like previously I just give you the definition like this is this should be wrong. This should be the slope divided by, not the slope, the vertical distance divided by the slope. I just said that it's I just said that it's vertical distance divided by the horizontal distance, was not.
Right.
So that's
I know. Why is that? Like, why is the other one wrong? Like, I thought the other one seemed kind of right, because it's like, the slope is 5% and slope is rise over run, right? So it should be the V vertical divided by the H. Like, how come it's V over S?
I think this is this is the one that from the textbook they have their specific definition about the slope. I did not recall all the definitions about the slope in the from the textbook. This is one textbook I shared with you in the first note. But there will be many different definitions about the slope. You can use the percentage. You can also use the angles to show the slope. But this is one definition from it.
Oh, all right. So slope is in this thing vertical by like the actual slanted distance.
Yes. Yes. Okay. If you don't have, there will be one more slide. So there will be some other errors in your measurement, the random error, which were caused by the limitations of the human beings when you are trying to observe the measurement from the tape or from the other instrument. And also there will be some mistakes. This would be some part you can avoid by following the standard operations of this instrument. And if you pay attention to everything carefully, you can avoid those mistakes. The typical mistakes, like if you do the measurement with tape for multiple times, you probably will drop one full tape length, or you add one full tape length, or you probably add an additional foot or additional centimeters, decimeters in the in your recording, or you have the wrong readings about the point you have to measure it, or you read the number incorrectly, or you read something but someone did not record it correctly. So this would be something you can avoid by repeat the measurement multiple times. So those would be the errors exist in the distance measurement, and we still have 3 minutes. I will try to I'll try to give you some explanation about the questions in the quiz. So we conducted this quiz last week, and there will be two simple examples, two simple questions about the zenith angle and the horizontal distance. So first, in this problem, we assume that the zenith angle of one sloping ground is 75 degree 42 minutes, and they want us to find out the vertical angle. So this is to do this problem, to solve this problem, we first draw the this is a horizontal line, and this is a vertical line, and the direction for this for the line. Say that the angle here, this is the zenith angle. The angle here is 75 degree 42 minutes. And we want to find out the vertical angle. Here, the vertical angle in this graph will be represented by the angle here. And clearly you can see that the vertical angle, theta equals 90 degree minus zenith angle. So that is a 90 degree minus 75.42 for 79 degree 42 minutes. So that is 89 degree 60 minutes minus 75 degree 42 minutes. So if you do the calculation, you can find out the result as 14 degree 18 minutes, which would be the B, answer of B. But it's not necessary to be B for your question, because I randomized the choices. The right answer is 14 degree 18 minutes. The second one is about the horizontal distance measurement, and we know in the problem we know distance between 2 points A and B, and the slope is the slope ground is measured as 147.56 meters, and we know the vertical angle is 4 degrees 32 minutes and 45 seconds. So what you need to do is, like for this problem, you know theta, you know the S, and we want to find out the horizontal distance. So basically for this one, the horizontal distance equals to S times cosine theta, and S is 147.56, and cosine of, if we have a calculator about how to use the degree, minutes, and seconds to find out the cosine, it will be quite easy. But if we don't have that one, if you say that you are using Excel, you need to convert the angle from radian. And for that conversion, you need to so theta is 4 degree 32 minutes and 45 seconds. what you need to do, like you convert them to degrees. So it's a 4 degree plus 32 divided by 60 plus 45 divided by 3600. So this is the degree. And then you have to convert the degree to radian. To do that, you need to divide this one by 180 times pi. Pi is 3.14. And then with that, you can use the cosine function. And the result will be 147.10 meters. So that will be the D for this question. So that would be the answer for the 2 questions in the quiz. Do you have any additional questions about it? Okay. If there's no question, I will think that will be all for the lecture today. And I'm sorry that I don't have time to go through the questions in the meeting chat. There's too many chats there. I will try to go through them after class, and if there's any interesting questions, I will try to record it and save it for the next lecture. Okay, so I guess that will be all for the lecture today. Thank you very much for your time, and I will see you tomorrow. And in the meanwhile, let me know if you have any questions.